So hello, my name is Daniel Estrada, and this is my advanced concepts presentation 4. So in order to go from glycolysis to the citric acid cycle, we must first harvest pyruvates into acetyl-CoAs. This process involves many small steps which result in the main entrance in the citric acid cycle. So we are to walk the audience through every step that is involved in generating acetyl-CoA from pyruvate, and we are supposed to focus on any cofactors needed, and we need to show how this process is reset at the end to allow for another pyruvate molecule to bind. So going into the first slide, this shows cellular respiration, which can be broken down into 4 main steps, which are glycolysis, pyruvate oxidation, the Krebs cycle or citric acid cycle, and oxidative phosphorylation or the electron transport chain. So for this advanced concepts presentation, we are focusing on the pyruvate oxidation, which is the second step of cellular respiration, and in this we will see how acetyl-CoAs are formed from pyruvate. So going over pyruvate oxidation, we can see this taking place in the mitochondrial matrix in eukaryotes and the cytoplasm in prokaryotes. So when looking at pyruvate oxidation, oxidation process, we can see that it is broken down into 3 main steps, as you can see here. The first step being a carboxyl group removed from pyruvate, which releases carbon dioxide. The second step is the 2-carbon molecule then loses electrons through oxidation, and the electrons are picked up by NAD+ to form NADH. And in the third and final step, the oxidized 2-carbon molecule is attached to coenzyme A to form acetyl-CoA. And once this is achieved, the acetyl-CoA can carry the acetyl group to the Krebs cycle. So all these steps involved in the pyruvate oxidation take place in the pyruvate dehydrogenase complex, or PDC. So the PDC consists of 3 enzymes, which are pyruvate dehydrogenase component, or E1, dihydrolipoyl transacetylase, or E2, and dihydrolipoyl dehydrogenase, or E3. There are also 5 coenzymes in this complex, which are thiamine pyrophosphate, or TPP, lipomide, flavin adenine dinucleotide, or FAD, coenzyme A, or CoA, and lastly nicotinamide adenine dinucleotide, or NAD+. And then here at the bottom, you can see a diagram of the pyruvate oxidation, which we'll be breaking down in the next few slides. We start with pyruvate, then we have decarboxylation, oxidation, transfer to CoA, and at the end we have a resulting product of acetyl-CoA. So going into the first step, which is decarboxylation, pyruvate is combined with the carbanion of TPP, then goes through carboxylation, resulting in the product of hydroethyl TPP, and it is important to know that this is the rate-limiting step in the synthesis of acetyl-CoA. In step 2, oxidation, next the hydroxy ethyl group from the product of step 1, which is right as you can see here, hydroxyl ethyl TPP. So the hydroxyl ethyl group is oxidized to form an acetyl group and is transferred to lipoamide. The disulfide group of lipoamide is then reduced to its disulfyl form to create acetyl-lipoamide. So we can see the product from step 1. being oxidized to form an acetyl group, and then it's transferred to lipoamide. So step 3, which is transfer to CoA. The acetyl group from the product of step 2, acetyl lipoamide, is transferred to coenzyme A to form acetyl-CoA, and this is the final step in the synthesis of acetyl-CoA. So the next step basically just allows for the process to reset. So you can see here the acetyl group from the product, which was acetyl lipoamide, is transferred to coenzyme A. So you just see the replacement. It's hydrogen right here with the acetyl group. So in step 4, this is typically the regeneration of enzymes. So the pyruvate dehydrogenase complex cannot complete another cycle until the dihydrolipoamide reacts with FAD to form lipoamide once more. Next, 2 electrons are also transferred to an FAD prosthetic group of the enzyme, then to NAD+, forming NADH. So this is just the regeneration step, so the cycle can continue again. So here we have steps 1 through 4. So we can see the decarboxylation, in which the pyruvate and the carbanion of TPP result in hydroxylethyl TPP. Then the oxidation, which is step 2 of hydroxylethyl TPP, and the creation of acetyl lipoamide. And then we have transfer to CoA, transfer of that acetyl group from acetyl lipoamide to coenzyme A, forming acetyl-CoA. And then the regeneration, the last step again, which was dihydrolipoamide reacting with FAD to form lipoamide once more, and 2 electrons transferred to NAD, forming NADH. So this is my explanation of this project, and I look forward to seeing everyone else's.